In this video, I want to talk about the law of total probability. Let's suppose A1 through AK are disjoint and make up the entire sample space. The law of total probability then says that the probability of an event B is equal to the probability of A1 times the probability of B given A1, plus the probability of A2 times the probability of B given A2, etc., all the way up to the probability of AK times the probability of B given AK. To see what's going on with this law, let's look at this picture here. In this case, I've broken up my sample space into 4 pieces, A1, A2, A3, and A4. And this oval here is event B. So the first piece says event A1 happened, and then the probability that B is in A1. So it looks at this piece right here. The second one, we assume A2 happened and look at the probability of B assuming A2. So that would look at this piece here. The probability of A3 tells me that I'm in this rectangle, times the probability of B given A3. So now I'm considering this piece here. And then finally, the probability of A4 times the probability of B given A4 looks at this piece right here. And then we add them all up to get the total probability of B. Let's suppose 2 friends will be dealt a card each. The 2 cards will be drawn from a standard deck of 52 cards at random and without replacement. If neither gets an ace, the full deck is reshuffled and the 2 cards are again drawn without replacement. The game ends when at least one of the 2 friends gets an ace, and the one with the ace wins a prize. So is this a fair game? Well, the probability that player 1 gets an ace, there are 4 aces in a deck of 52 cards. This game is fair if the probability of player 2 getting an ace is also 4 over 52. In order to consider this, we need to break it up into 2 cases. Player 1 drew an ace, or the second case, player 1 did not draw an ace. There's a probability of 4 over 52 that player 1 drew an ace. And in this case, there are still 3 aces in the deck, but 51 cards. So this would be the probability of the second player getting an ace. The probability that player 1 did not draw an ace is 48 over 52, since there are 48 cards in a deck that are not an ace, times there are now still 4 aces in the deck out of a total of 51 cards. And if we work this out, we get 4 out of 52. So yes, this is a fair game. 2 consecutive traffic lights have been synchronized to make a run of green lights more likely. In particular, if a driver finds the first light to be red, the second one will be green with a probability of 0.9. And if the first light is green, the second one will be green with a probability of 0.7. If the probability that a driver will find the first light green is 0.6, we want to find the probability that a driver will find the second traffic light green. So we want the probability that the second one is green. Well, we need to break this up into 2 cases. The fact that the first one was green, and then the probability that the second one is green given that the first one was green, or the fact that the first one was red, and then the probability that the second one is green given that the first one was red. So these are my 2 cases. The first was a green, or the first was red. Well, the probability that the first light is green is 0.6. The probability that the second is green, given that the first light is green, is 0.7. We then need the probability that the first light is red. If it's green 0.6 of the time, then it's red 0.4 of the time. And then finally, the probability that the second light is green, given the first light is red, is 0.9. And then we can work this out. And when we do, we get 0.78. So the probability that a driver will find the second light green is 0.78. In a certain county, 60% of registered voters are Republicans, 30% are Democrats, and 10% are independents. When these voters were asked about increasing military spending, 40% of the Republicans opposed it, 65% of Democrats opposed it, and 55% of independents opposed it. So what's the probability that a randomly selected voter in this county opposed increased military spending? So we want the probability that they opposed it. Well, we have a few things that could happen. We have to consider the chance that they're a Republican, and then the chance that they opposed given that they were a Republican. They could have also been a Democrat, and the chance that they opposed given that they were a Democrat, or they could have been an independent, and then we need to consider the probability that they opposed. Well, there was 60% Republicans, and 40% of those opposed. 30% were Democrats, and 65% of those opposed. And 10% were independents, 55% of those opposed. And if we work this out, we get 0.49. So that was a 49% chance that a randomly selected voter in this county opposed increased military spending.